Hi, this is King of Review. If A is an invertible square matrix of order 2, find the value of A plus B. Now A plus B are these entries here, and we're given 3 equations. So I want to start by trying to format these 2 equations in a way where I can get A inverse. So let's start with the A squared equation here. So we have A squared, which is matrix A squared, times the matrix 6, negative 3, equals matrix 1, negative 4. Now, what's another way to write A squared? Well, we can write that as A times itself. That's the same thing as A squared. So A times A times the matrix 6, negative 3 equals matrix 1, negative 4. Now the next thing I want to do is to try to use this equation here. So you notice we have a matrix that has a negative 2 and a 1 in it, where the A squared equation has 6 and negative 3. So I'm looking for a number that I can multiply, so some number that I can multiply by this matrix to give this matrix here, which has 6 and negative 3. So what number times negative 2 gives 6? And that same number times 1 gives negative 3. Well, that would be a negative 3. So now I can write this as negative 3 times matrix A times matrix A times negative 2, 1 equals matrix 1, 4. 1, negative 4. So again, if we multiply negative 3 times this matrix, you end up with this matrix, 6, negative 3. Now remember here that A times matrix negative 2, 1 equals matrix negative 1, 1 here. So what I want to do is substitute this value in. So you can see that this portion here is right here in our equation. So since A times this matrix negative 2, 1 is equal to that, I'm going to substitute this matrix in right here. So I have negative 3 times matrix A, and I'm substituting in this matrix here, negative 1, 1, equals matrix 1, negative 4. So again, remember, I'm trying to get to this equation here because I want to solve for A and B. So I'm going to multiply both sides by A inverse. So we have negative 3 times A inverse times A times our matrix that has negative 1 and 1. And this equals A inverse times matrix 1, negative 4. Now I want you to remember the fact that if we have matrix A times its inverse, which is A inverse, this is going to equal an identity matrix. Remember, an identity matrix has 1s in the main diagonal and 0s everywhere else. And one feature with the identity matrix is that if you multiply a matrix of the same dimensions times an identity matrix, you'll get the original matrix. So if we have A times the identity matrix I, you're going to end up with the original matrix. Or if we have I times A, you will still end up with A. So if you notice here, we have A inverse times A. So we know that this is going to be an identity matrix here. So we have negative 3 times the identity matrix times this matrix, negative 1, 1, equals A inverse times the matrix with 1 and negative 4. And again, remember that a matrix times an identity matrix gives you the original matrix. So what we have here is negative 3 times the matrix, negative 1, 1, equals A inverse times this matrix. So the next thing I want to do is multiply each of the entries within this matrix here by negative 3. So I have negative 3 times negative 1, that gives me a 3, and negative 3 times 1, that's equal to negative 3. And this equals A inverse times the matrix that has 1 and negative 4. Now if you notice here, we have A inverse times the matrix with 1 and negative 4, and that's what we see up here. And we know that this is equal to the matrix that has A and B in it. Therefore, we know that A is equal to 3, and we know that B is equal to negative 3. And we were asked to find A plus B. So A plus B is equal to 3 plus a negative 3, and this is equal to 0. So 0 is the final answer. Thanks for watching.